Now this illustration deals with grounded systems. And basically, this is in accordance with 250.130A. But now reviewing the transformer, notice that that Y-connected secondary is connected to ground, the XO is. And then the note 1 says we're just showing the secondary wiring, basically. Now, the grounded system with the grounded neutral conductor would be sized from 250.102C1 based upon the ungrounded phase conductors, if we've mentioned a number of times through this chapter 16, if you've been reviewing the entire chapter. But 250.24A and 250.142A1 deals with supply side, and we know this is supply side grounding we're talking about here because the transformer conductors that are tapped, transformer and secondary conductors routed to the main through the conduit. There's no overcurrent device ahead of them, so that is supply. So what this is pointing out, if the transformer's grounded, then the service would have to be grounded, and we would meet 250.24. We would also then comply with 250.142A1 using the grounded conductor from the transformer to the service equipment that you see. So 250.24, we're grounding the outside transformer, and we're grounding the service equipment, and we're grounding in accordance with Table 250.102C1. Now, to close this illustration out, the grounded conductor from the secondary side of that transformer to the main has to be routed with the phase conductors. The equipment grounds that you see have to be routed with the phase conductors. And if you have a neutral equipment ground, both of them have to be routed with the phase conductors is the basic rule. And then the main bonding jumper that you see in the illustration could be a conductor jumper, could be a screw, could be a strap, could be a bus, other effective means that would be approved by the authority having jurisdiction. Now that's what this figure 16-116 is illustrating for grounded systems in accordance with 250.130A as in Apple.